Well, friends, we have loaded the file here, and here you can see that we have started the PA fans, but the PA discharge header pressure, that is 326 or 329 something, it is increasing. Actually, we want there more than 640, then only we can start the pulverizer. So that will be going on increasing before, but we have to open the cold air gates. So we will be opening the cold air gates. We go to the field page number 3 and open the cold air gates of all the mills. So if the mill is not available or under maintenance, that should not be opened, or otherwise if all the mills are available, open all the cold air gates of all the mills. Now we have opened the cold air gates of all the mills from A to F, or 1, 2, 3, 4, 5, 6. The PA header pressure is still 474, it is increasing. Now we go to the mill and coal feeder, and here you will be able to see the cold air dampers here, or yes, these are the cold air dampers, hot air and cold air dampers. You can see cold air C, hot air discharge damper C, cold air damper B. We slightly open the cold air damper B, so that through that some flow will be maintained, so that the PA header pressure will not rise very much. So we open this damper slightly. Then we go to the uh, yes. Now we will go to the cold air damper of A and hot air damper of A. We raise it slightly, we open it slightly. Cold air damper A also we open slightly. Now we will again check whether the PA header pressure has reached to a certain level. We want more than 640, so we will just check up, go to the fan and air heater panel, and there we check up how much. Now it is 731, means it is more than 640. So now the uh, pulverizer ready signal will be there. It is almost 759 or so. Now we put the PA fans on auto, PA header pressure on auto. The set point is something 800 millimeters of water column. So it is almost 800. So we go to the FSSS panel, and we want to open the pulverizer discharge gate. Pulverizer discharge gate for A mill. So we give a start command, but you see that it is not opening, it is again stopping. So there is some problem, that we will see what is the problem. So we come to the fan and aerator, and here you will see that both the PA fans are running, but for the coal mills you want the seal air fans. So we put the seal air fan switch on auto, so that both the seal air fans will start, and then you can go to the mill and coal feeder FSSS panel, and there if you open the pulverizer discharge gate, the pulverizer ready indication would be there. So it is there, pulverizer ready indication is there. Now you can start the coal mill. So coal mill cannot be started unless and until you have the seal air available. Otherwise all the dust will come out through the coal mill. So once the seal air is available, then the pulverizer ready signal will be there, and you can start the mill on, you can make the mill on. As you make the mill on, you will see that the mill amperes are showing there. First a kick would be there, and a normal around 20 or something. Then you can open the hot air gate also. Now once you have opened the hot air gate, you are able to see the PA flow. So you can go to the coal mill and feeder panel, and there you are able to see the PA flow, that is rising. Now it is 9.73310, something like that. And you can see the mill temperature above that also, mill A temperature, that is also 35.136, it is rising. So we let the temperatures, we supply the PA air, hot PA air to the mill, so that the temperature increases. So when the temperature reaches to beyond 60 degrees centigrade, then only you can admit some coal inside the coal mill, or otherwise the coal mill may get choke up. So and it will not allow also. So once the temperature is more than 60 degrees, then the pulverizer discharge header discharge temperature low, that in that signal would not be there, and then you can start the feeder, otherwise the feeder will trip. So this interlock is there. Now the temperatures are rising, similarly the PA flow, that is also increasing. We again go to the fan and air heater and check up whether the PA header pressure is being maintained. Yes, the PA header pressure is being maintained. It is presently 789 point something. So it is on auto, and you can see that the pressure is being maintained. So we check up that. Then we go to the again FSSS panel, then mill and coal feeder panel. So here you will see that the temperatures are rising. Now it is nearing 40 degrees centigrade. We increase the PA flow to mill still further. Actually, we want the mill PA flow to be around 50 tons per hour. Now it is 27 tons per hour. So we go on increasing it, and at the same time the mill temperatures are also increasing. Now as the whole body is being heated, mill body is being heated, it will rise, the temperature will rise slowly, so and gradually, so that you have to raise it gradually, not suddenly. So it will take some time. Now it is 41, temperature is 41 degrees, 41.4 degree, like that, and the PA flow is also there. We still increase the PA flow, and we want to, once it comes to 45, 47 or around 50, we put the PA flow, mill PA flow, coal mill PA flow, that is hot air flow, hot air damper, you can put it on auto. So it will maintain the PA flow. Now you can see here the set point is 52.30 or something. You can see on the you can change the set point also, but here the set point is 53 point something. So if you put on auto, it will try to maintain that much of flow. At the same time, we will be just going through the normal parameters, whether the drum level is normal or not, that we check up. Then the flue gas temperatures, whether they are, because we have not yet taken the coal cycle in service, means the coal feeder is not in service, and that's why the temperatures will be normal, just like you had when you had all the guns, those are being fired. Now here you see that the PA flow has gone to 40 tons per hour, and the temperature of the A mill is around 48, 49, something like that. So it is still rising. We have to wait up to 60 degrees, and then only we can start the feeder. Once the temperature reaches more than 60, then you can start the feeder. But till that time, you should check up always the drum level. Though it is on auto, you must check up the drum level, the temperature, the flue gas temperatures, and all these trends you have to see. Now you see that the mill temperature is rising, but the PA flow is something around 39 or so. So we may increase the PA flow a little bit, so that the temperature will also rise. So we increase the PA flow. We have put the cold air damper on auto. The cold air damper on auto will maintain a means at 75 degrees centigrade. The if the temperature reaches to 74, 72 here, I think, I am not able 75 degrees. If it goes more than 75, then the damper will open. Otherwise, the damper will be closed. It is on auto, the damper will be closed. Now you see the PA flow has, I have raised the PA flow, opened the damper and raised the PA flow to 47, 48, like that, so that I can put the damper on auto, and it will maintain the flow. So it is slowly increasing. The damper is around 85 to 90%. So I have put the damper on auto, and now it will take care that the flow is 52, around 52 tons per hour. Now we go to the fan and air heater panel. Here you will be able to see that the PF header pressure is being maintained to 800 millimeters of water column. That we check up. Then the mill temperature has risen to more than 60. So, and now it is rising fast, so now we can start the feeder. Now this is the uh, feeder controller, so you can increase or decrease the speed from this point. But for starting the feeder, you have to go to FSS panel, and here you can give the start command to the feeder A on off. Now as you have started the feeder, you will see on the mill and coal feeder that the minimum feeder RPM would be there. So the minimum feeder RCFA RPM is around 12. So we put this on minimum feeder RPM. At the same time, we also check up. Now immediately the temperatures are not going to increase, but immediately the temperatures will not increase. But till the time you can see, because you have opened the PF flow gradually, the total air flow has increased. So the total air flow, you can see that it has increased. Now you see the PF flow to mill is 52, it is being maintained on auto, and the mill temperatures are nearing 70. So we go to the, now we have started the feeder. So we have started the coal mill, means we have taken the coal mill in service. So we go to the FSS panel, then we check up with the everything is okay. The scanners also we will check whether the yes AB flame is there, and A flame will also be shown. If you go to still that side, you will show that A B C D E F flame is not there, but A B and C D flames are there because you have got oil support in A B and C D both elevations. Now one more important thing is there are fuel air elevation A coal air damper, so that has to be put on auto. So as you put this on auto, it will open according to the feeder speed. Now only A mill is running, so only A will be opening something on auto, that will be shown here. Rest of the mills, when we take the mill, we will put them on auto so that they will open. Now here the fan and air heater, as you see, we have given the air to the coal mill. Now the primary air has increased, and that's why the total air flow has increased. So we will decrease the total air flow to the position where, because this air is being given by the FD fan, and the PF fan air was also given. So we will reduce that air flow to the original level. So it was around 280 or 300. So we have reduced it slightly, and now here you can see that the total air flow has reduced slightly. Very slight reduction would be there, as around 51 tons that was taken from the PF fan. That much reduction would be there. Now the flue gas temperatures also, as we have taken the coal mill in service, they would start rising. So you see a rising trend there, and still it has not appeared, but it will appear a little bit. It may take a little bit of time. So the coal feeder A RPM, we increase the coal feeder A RPM from minimum 12 to 17. 12 to 17. So we increase the RPM to 17.280. So some coal will be, now minimum means some minimum, and some coal was going, but now the coal quantity has increased, and now you can see that the flue gas temperatures are there increasing. So flue gas temperatures are increasing. Similarly, the load will also increase, but you have to restrict it to around 30 megawatt. So we will take care that if the load goes beyond 30, then we will reduce the CVSM and the control the load to 30 megawatt. So with one coal mill, we'll control the load to 30 megawatt, and then we load further, and then we increase the load further. So with this, it is one more thing is there. FSSS panel, we go to the uh, we check up with the CVSM also during this period whether the CVSM is full open or we have throttled it. The CVSM seems to be full open as the CVSM is showing 300 mm. So the CVSM is full open, and we are not to worry about the reducing the load, because the load is just increasing 30 megawatt. And if you want to reduce the load, then you can, means that will increase the boiler drum pressure. So you can reduce the load when it goes